Students, if resistance increases, will voltage always increase? With internal resistance in the circuit, things change. As R increases, what happens to V? Let's predict the correct graph using Ohm's law. Let's start the problem. A cell having an EMF epsilon and an internal resistance r is connected across a variable external resistance capital R. As the resistance R is increased, the plot of potential difference V across R is given by. There are four graphs are here. By Ohm's law, as R increases, the voltage has to increase. Let's see the right one. So we have an EMF and an internal resistance and a variable resistor R. The value of R increases. Okay, good. There is a current I. Let's start with Ohm's law. Epsilon equals I times R plus small r. Now let's find I. I equals epsilon divided by R plus small r. Let's continue. So V equals I times R. So instead of I, let us substitute epsilon divided by R plus small r multiply capital R. Let us bring this capital R down to the denominator. So we get V equals epsilon divided by 1 plus small r upon capital R. Now let us have two cases. When capital R equals 0, then small r by 0 becomes infinity. So infinity plus 1 is infinity. Epsilon divided by infinity is 0. So V is 0. When R is 0, V is 0. Then when R is infinity, what we get? R divided by infinity. 1 divided by infinity is 0. So 0 plus 1 is 1. So V equals epsilon divided by 1. It is epsilon. So there are 2 points in a graph we get. One is 0, 0. The other one is infinity epsilon. So let us draw the graph. So we choose 2 points. One is 0. For R equal to 0, the voltage is 0. So it is an origin. Then when R increases to infinity, then the voltage gradually increases to epsilon. So option C is correct.